Hello. This video is going to talk primarily about interfaces. You've used an interface in some cases, perhaps without knowing it. Possibly you did know it. So an interface is similar to an abstract class, except it has all abstract methods. It can't be instantiated, and all the methods that are listed in the interface have to be instantiated in another class. So you use the keyword interface instead of the keyword class to define the header, and the method, there are no method bodies. The method headers are terminated by semicolons. So here's the definition of an interface. Interface name is your choice, unless it's a library interface, of course. And here is an example of three method headers that are implemented by relatable interface. Now in this case, on the left, graded activity does not implement relatable, so it doesn't need to have those in it. Now we implement relatable, and yes, we do have to instantiate or implement the three methods that come from relatable. The compiler will tell us if we haven't done that. Here's an example of Final Exam 3 that implements relatable because it extends graded activity. In this case, it just calls the three methods in graded activity. It is possible to have a field in an interface, although that's not normally what we do. But a field in an interface has to be final and static. And if it's final, you basically have to provide an initialization. So final variables are, by naming convention, are capitalized. And so that's an example of two fields in an interface. You can implement multiple interfaces. You can only have one superclass in Java. There's no multiple inheritance. There's only single inheritance. But you can have multiple interfaces. So the UML symbol for interface is a dotted line with a closed arrowhead. The second one down here is an example of it. So you've dealt with event handlers, is an interface in GUIs, and it takes an element of type action event, and you have to implement the handle method. Now you do have the ability to create reference variables of an interface type. So that's an example of polymorphism. Let's take this example of a retail item interface and two classes, one called Compact Disc, the other called DVD Movie. Now, for those of you youngsters, those were real things a few decades ago. So they are retail items. They both satisfy the is-a relationship. But you cannot instantiate a retail item. That's an error. You can't instantiate it because it's an instance. You can't create an instance of an interface. So when you use a reference variable that is related, is an interface reference variable, and you point to an object, the object has to be a class, and only the methods are available. You can't use other methods unless you typeclassed with if you know what the class is, you could cast it. So here's an example of compact disk that implements retail item. Retail item gets, the only method it requires is get retail price, and there's get retail price down below. Same thing with DVD movie. Still the same interface, but its own instantiation of the method. Here's the driver. So in this case, you have the possibility of multiple items being listed by show price. In fact, show price movie and where is show price CD. You cannot, however, use a method like get title that is specific to the class and is not in the interface. So there is a class called arrays, which allows you to manipulate arrays and allows arrays to be viewed as lists. The sort method is overloaded, and it specifies the natural ordering of its elements. What is the natural ordering? Well, it's whatever the programmer decides. So for strings, it's alphabetic order. So elements in an array that uses the sort object and uses arrays.sort have to implement the comparable interface. And comparable tells you what the natural ordering is. Here are all the known classes that implement comparable. So comparable requires you to implement compare to. I've talked about that before. And there's the mathematical definition down below. It basically means that the object compared to O in this example, in this Java doc, if that's in the correct order, then it returns a negative integer. If it should be swapped, if, for example, O should come before the object, then it should, then compare to should return a positive integer. So if you had these this class student and you wanted to sort them, you would need student to implement comparable and give a body to compare to, like this. The same thing works with collections, the collections class, and the natural order. They have to also implement comparable. So array list implements list, and that implements comparable. So you can compare array list elements. Strings implement comparable. When strings are elements of array list, you can sort them using collections. So once again, if you had an array list of these objects, of student objects, you would have to do the same thing. You would have to implement the comparable interface and implement compare to. Now, in Java 8, interfaces could have default methods. That makes them a lot closer to abstract classes, but the reason is that we don't want to have to go back to everything that implemented an interface in Java 7, for example, applications that implemented interfaces in Java 7 or earlier, and rewrite that code so that they all have default methods if we wanted to use the interface from Java 8. So here's an example of an interface without a default method. And then when we put it in there, when we put the default method in, we just add the keyword default and the method and implement the method, instantiate the method in a normal way. An anonymous inner class. So oftentimes we name a class and then we can use it. But if we only are going to define it once and use it, then you could put it as an inner class, and it could be anonymous if it had no name. So here's an example of int calculator. The anonymous class square, it's not named, so it's anonymous, and it implements int calculator, and the code knows that since it's got the reference variable int calculator, that it's going to need to instantiate or implement calculate. So it knows that, and if it didn't have it calculate in there, it would cause an error, a compile error. So there are numerous cases where there are interfaces that have only one abstract method. Those are called functional interfaces. And you can use a lambda expression with a functional interface to create an object. A lambda expression, we don't normally use the lambda expressions because it's a little bit complicated and obscure, but when you're writing lots of code, you can easily figure out how to write lambda expressions. This same example, square, this is a lambda expression. The right pointing arrow or dash greater than sign, which represents a right pointing arrow, is the lambda symbol. And obviously square takes a value x and multiplies it together. And then the square could be used later on. So that expression, that lambda expression that's circled in red, means the same as this anonymous method over here.